to not multiply the row that you're trying to change by its negative, a negative multiple.
Yeah.
But I see that we do that. Is that actually?
Yes. Where did it say that?
In the textbook?
Yeah, it said not to scale the equation before you start using it somewhere.
I'll look for it.
Yeah, no, I remember what you're talking about. And it said it in a particular context. I don't remember the exact context, but what, you're talking about scaling it or specifically by a negative?
By a negative. But when we do our row
No, row operations.
It said not to. I keep forgetting how to access the book on this thing.
Anna?
Oh, yes.
We're gonna do 29 and 31 from last chapter, but 29 we're gonna do fresh on a fresh sheet of paper. Okay. Okay, so here we go, folks. Learn anything else? Let me know. Maybe over break.
I'll find it.
Yeah. So 29, and Nick, this is going to be like a
For you.
super crash course for you. So we want to solve this linear programming problem where we have two constraints, right? We've got our constraints that y1 and y2. Also know that if you double y1 plus y2, it needs to be at least 24. So those are our constraints. And then w, that's our what? What's it called?
Our objective.
Objective function. Maybe that calculates profit. So we're going to get $5 in profit for machine 1, $2 in profit for machine 2. And so we're wondering, what combination of machines should we make to make the most profit? Or actually, in this case, we're trying to minimize. The problem is a minimized problem, so we should be talking about cost. We want to minimize the cost. So this was our cost function, actually. But we need to make at least this many products. So how do we minimize the cost while staying within those constraints? If we were just to do that problem all by itself using a graph, that would be fine. We could just do a graph. And so once you actually solve those two problems, I think one of them would look something like this, and then the other one would look something like that, and then you would end up with this material, or this area right here, this strange looking quadrilateral. And then what would you do from there? Once you actually graph both of your constraints,
And your vertices.
you'd find your corner points, and what would you do with them?
Put them in your.
You plug them all into your objective function, and just compare which one's smaller. Nick, that might sound familiar to you. Okay, great, great. What we're about to do won't be. Hey there, Carmen. So, now, this is a minimum problem. And we didn't learn, the simplex method doesn't cover minimums. It only covers maximums. So, what do? We're going to capture just the bare minimum information from this, namely our two constraints. So, one constraint is 1y1, 1y2, and 19.5. And our other constraint is 2y1, 1y2, and 24. And then the other information we put in is our objective function, just the coefficients. So that's going to be 5, 2. And by definition, this bottom entry is always 0. Nick, this should look something like magic to you right now. Like, why are we putting these numbers here? What's happening? But what we're going to do is take this minimization problem and we're going to turn it into a maximization problem. Where, in this reality, we're trying to find the smallest value of w, but I'm going to change the problem so that we're trying to find the largest value. Okay, so now what do I do with my matrix, folks?
You transpose.
Transpose, you take the transpose. So every row becomes a column. So 1, 1, 19.5 becomes 1, 1, 19.5. And 2, 1, 24 becomes 2, 1, 24. And 5, 2, 0 becomes 5, 2, 0. Nick, that's called a transpose. You swap the rows and the columns. All right. Now, whereas over here, this was y1, y2, and it was a minimum problem. Now over here, we're going to call this x1, x2, and this is now a maximization problem. Whereas over here, we were trying to minimize the objective function w equals 5y1 plus 2y2. Over here now, we're going to try to maximize the objective function z equals 19.5x1 plus 24x2. How does everybody feel about that so far? We just altered the problem into a new problem. And so now we have our objective function that we now want to maximize. We now have new constraints. New constraints. The previous constraints were greater than or equal to. So Nick just took a huge guess here. What are our new constraints going to be?
Less than.
Very good. So now our new constraints are 1x1 plus 2x2 should be less than or equal to 5. And 1x1 plus 1x2 should be less than or equal to 2. And there we have it. At this point, the transformation is complete. We now have turned our minimization of W problem into a maximization of Z problem. And since it's a maximum problem, we can use the simplex method. Now, before we can use the simplex method, we now have to take all this and put it back into our initial
Simplex
tableau. Initial simplex tableau. So I'm going to put mine over here. And our constraints come first. I'm going to have an x1 and an x2. But I don't want this to be an inequality. I want it to be an equality. So what do I need to introduce? A slack variable. So I'm going to introduce slack variable 1. And we're going to say 1x1 plus 2x2 plus 1s1, which is my slack variable, should equal exactly 5. And of course, we're going to leave some space there. We need some space because we're going to introduce another slack variable and our z before we can finish off our matrix. Nick, I really care about you. I want to bring you along on this journey. We're taking 1x1 plus 2x2 less than or equal to 5, and we're saying, well, since this is smaller, if I just add another term in there, which I don't know how big it needs to be, but if I just add another term called a slack variable, I can make it equal to 5, if I just know how big s1 is. So we want to make it equal to 5 so that we can actually solve a system of equations using matrix methods. So that's what a slack variable is. Okay, next. What would the next constraint be, Daisy? I'm sorry, yeah, what's the next constraint?
1.
Yeah.
0.
0.
1.
1, because we have our next slack variable now, and then?
0.
Yeah.
2.
Yeah. And by the way, those were both zeros, right? So our next equation, Nick, becomes 1x1 plus 1x2 plus slack variable 2, a second slack variable, so that that's now equal to 2. Okay, so we've got both of our constraints. What's the next row going to be, Shemaya? Our objective function, what do we have to do to it? Bring all of our terms over to the left, so it's negative 19.5x1 minus 24x2 plus z equals 0. We need to transform our objective function so that all the terms are on the left with a positive z. So Shemaya, how do I put all that information into here? Negative 19.5. Negative 24. No slack variable, no slack variable.
1.
1, and then 0. Okay. That is our initial simplex tableau. So, our goal, what's our ultimate goal? It's about the bottom row. What do we want our bottom row to be? All positive. Well, non-negative. It's okay if there's some zeros in there, but it has to be non-negative. So we want it to be positive. So we had a few steps about the simplex method. Who would like to tell? Well, step 0 was simply to write the initial simplex tableau, which we have just done. What was the first step?
You have to take the most negative number.
Yep.
Choose negative 24.
Yep, so choose the most negative indicator. So, the bottom row, Nick, these numbers are all called indicators, and you choose the most negative one. So this column, somewhere in that column, we're going to choose one of those numbers. And then, so we've chosen the most negative indicator. How do we choose which of them? How do you choose your pivot?
5 over 0 minus 0 over 1.
Yeah, so now we're going to choose the smallest quotient. And by quotient, we mean, what if you just temporarily pretend that you have the equation 2x equals 5 and 1x equals 2, and you just solve both of those, 2x equals 5 and 1x equals 2. What's the smaller answer? So here, x would equal 5 halves. So that's that quotient, 5 halves. And here, x would equal 2 over 1. So which one of those is smaller?
1.
Yeah, the 1 is the smaller quotient. 2 over 1 is the smaller quotient, because that's 2, that's 2.5. So this now is our pivot. That's our pivot point. And what we're going to do, Nick, is make them zeros above and below. Just like we used to do with row echelon form and Gauss-Jordan form. All we did so far was just choose which of all these numbers we're going to hold constant as a number and create zeros above and below. Okay, well, everybody, let's do it. So now, step 3, we create zeros. So let's do it. This is a nice review of the whole method that we did last time. Now, Lorena, you had just shared something.
And I did find it.
Okay, go ahead.
So it's page 147 of the textbook.
Uh-huh.
It has a little caution indent on it that says, in this chapter, when
Page
adding
147?
yes,
I'm on page 147. Oh, caution, yeah.
yes, that one. It says you can't add, we will never take a negative multiple of the row being changed.
Mm-hmm. All right, if you get a negative number in the rightmost column, you will know immediately that you've made an error. The reason for this restriction is it's violating, it turns negative numbers into positive, and vice versa. This is disastrous in the bottom row, where we will seek negative numbers when we choose our pivot column. Yeah, so it just basically means that it could make the whole problem harder because you're creating more negatives elsewhere.
Okay.
Yeah, and I guess what they're really saying is you don't want to do a small minus a big because it makes negatives.
Okay. So how I understood it is, for example, our pivot is 1. So if I want to get rid of the 2 on top, I would have to first do, well, I would multiply my pivot row by a -2.
And
And
then
I
add it
can't-
to that row.
Uh-huh.
And I think that's fine because we didn't add it into this row.
Okay.
I think. In any case, I think, let's go ahead and do it, folks. We want to eliminate the 2. So just trusting our normal row operation, trusting our normal row operations, if we want to get rid of that 2, we're going to multiply this whole row times -2. So that's -2, -2, 0, -2, 0, -4. We're going to add it into the top row. So what do we get?
-1, 1, 0.
Yeah, -1. Two markers are not working out. Oh no, stay there. Oh boy. Oh, yes, well everyone, you're all working on this, right? So -1, 0, 1, -2, 0, and 1. My middle row stays the same, 1, 1, 0, 1, 0, 2. And now, we want to make that -24 into a 0. So that's easy, right? What are we going to multiply our row by now? Since that's a -24, we want this to be a positive 24. So we multiply through the whole thing by 24. Oops, that's a 0. That's 48. And now our bottom row is what? 4.5, 0, 0, 24, 1, 48. Did we get it? So everyone else got it? So Lorena, we didn't actually do the thing you were worried about us doing. Right? Because didn't it say you're not supposed to multiply it by its own negative self and then add something into it?
Yes.
You'll never take a negative, yeah, you don't take a negative multiple of the row being changed. Yeah, that's what they said, okay. Okay, so folks, here's the exciting thing. First of all, are we done with the simplex method? Is the whole bottom row positive?
Yes.
Yes, we're done. We are officially done. And now what I want us to do is just take a look at what we have. This is x1, this is x2, this is our slack variable, this is our slack variable, this is z, and this is just a number. So one thing that we're interested in is the actual maximum minimum value of z. What's the maximum minimum value of z? 48. So z equals 48 is the minimum value achieved in this objective function, and 48 is the maximum value achieved in this objective function. That's what duality theory says. Duality theory says that when you transpose the matrix like that, the minimum of this function is equal to the maximum of this function, and we showed that graphically by suggesting that the maximum of this parabola is equal to the minimum of this parabola. That if you have two paraboles kind of touching at the vertex, then the maximum of one is the minimum of the other. All right, so here's the exciting part, folks. These two numbers right here, which we would look at and say that's S1, S2, at least that's representing those two slack variables, that is equal to the Y1 and Y2 that will produce that minimum. Does So I'm going to go ahead and write S1 is equal to Y1, which is equal to 0. And then S2 is equal to Y2, which is equal to 24. Those are the solutions for what you need to plug in over here to Y1 and Y2. And while that is a bold claim, let's just check it real quick. What happens if I plug in those values for Y1 and Y2 into this objective function for W? 5 times Y1, that's 5 times 0, plus 2 times Y2, that's 24. And what does it equal? 48. So indeed, it's a lot shorter and faster than maybe we might have guessed last time. That once you're done with the simplex method, where you really want to draw your attention is here, because it tells you the value of Z, and here, because it tells you the value of the original variables that you were looking for. Anna?
Yes, I have a question. So last class, you told us to circle that we have the 2 zeros like x2 and s1, right? So we only do that for section 4.2, and for 4.3, do we do it this way like you showed us, or?
Yeah, in the duality theory, it is confusing. In the duality theory, we're interested in solving the original problem, which is the minimum problem, which is Y1 and Y2 and W. And when you transpose it by duality theory into a maximum problem, you're no longer thinking about your basic variables and solving for x1 and x2. In fact, you don't even care about x1 and x2. What you're actually interested in is just finding the maximum value, which is here, and then knowing that the slack variables s1 and s2, given by these two numbers, are the solutions for y1 and y2 over here.
So would it always be the bottom two, or would it be?
Yep. It's these. It's always the very bottom of the matrix in the objective function row, and then that's it.
So like in another question, so we go back to the section 4.2, and so it'll be S1 will be 1 and S2 will be 2,
in
right?
the other section, we were saying, okay, here's a solution for x2, x2 is equal to 2, and here's a solution for s1, s1 is equal to 1.
So I won't get confused. Okay.
Yeah, that would be section 4.2. Does that sound right to everyone else? What Anna just asked? Did I give good guidance there? Shemaya, you raised your hand before Anna, and she just barged ahead of you. And
No, that was kind of similar, like, so when we're in section 4.3, we're going to solve and make sure the whole bottom row is positive.
Yep.
And then whatever's on the bottom row is going to be our.
Exactly. Whatever's in the bottom row is the answer. And this is so fun and exciting, we're going to go ahead and do number 31. Now 30, the only reason I crossed out number 30 is what? It's just because there's some decimals. But I mean, you know, there's nothing wrong with decimals. It's just that the matrix work gets a little heavy because of all the fractions and whatnot. I have always been more interested in concepts than dinking around with fractions and decimals. It's way more interesting to see how it works, in my opinion. Okay, so let's try it again. We want to minimize that objective function, subject to those constraints. But the thing is, and Nick, I didn't say this, this method right here is called the simplex method. The simplex method only works for maximization method or problems. So this only works if you're looking for a maximum. And right here, we're not looking for a maximum, we're looking for a minimum. So we can't just apply that to this. We have to transpose it. Okay, so folks, let's try it. Let's do it. What do I start with? Let's start
here.
Yeah, A equals, and then maybe I should just call on Nick because the poor guy wasn't here last time.
Yes, I agree.
All right, Nick, what's our first constraint?
Was it 3, 2, and 60?
Very nice. Our second constraint?
4, 1, 40.
And then our objective function.
Is 4, 2, 0.
Yeah, very good. 0, it's always 0. And now, remember, folks, this is y1, this is y2, and we're trying to solve a minimum problem. So it's helpful to just kind of keep track of that up there. Okay, so we transpose the matrix. And right here, this very moment right here, it must tickle your brain to think, why does this work? This is weird. Why does this even work? And well, it's the mathematicians who came up with this who proved that the theory works. We're just doing the shortcut. You know, we just get to benefit by doing what they told us worked. So Nick, go ahead and tell me, what's my new, tell me each row to put down as a column.
It is 3,
Yeah.
4, 4. You're going down.
Oh, you're going across? Here we go. 3, 4, 4.
2, 1, 2.
Yeah, 2, 1, 2.
60, 40, 0.
Oops. I've always taken a row and turned it into a column. And Nick took the columns and turned them into rows.
I just already done.
Are we allowed to do that?
Mhm.
Yeah, sure. Either way works. All right. And so now we have to pull all that information back out of here. So this actually represents x1, x2. This bottom row actually represents our objective function of 60x1 plus 40x2. And, and so since this was originally greater than or equal to, these are going to be, Nick?
Less than.
Yeah. So now we have all of our constraints, which I'll just write down for good measure. So 3x1 plus 4x1 is less or equal to 4, and 2x1 plus 1x2, 2, mind you, less or equal to 2, and that's my bit. Folks, we have done so many matrix methods since the beginning of this class, and so many different types, from echelon, Gauss-Jordan, the matrix methods on your calculator, and all that. Do you almost find this one satisfying?
Yeah.
What's so satisfying about it? I think it's satisfying.
Oh.
You know what I think I like about it? You don't have to turn everything to zeros. You don't have to do everything to zeros. You just have to do some of them to zeros. Okay, so what is our initial simplex tableau? Nick, you're going to try this again with the slack variable thing. It does help actually to write down the slack variable first. So this is, I have a 4 over here and I have a 2 over here. So instead of writing less than or equal to, I'm going to introduce a slack variable into this equation. So since this is our first constraint, we'll use S1, then we just write, here's my slack variable, so that that's equal to 4. Each constraint gets its own slack variable. So what would I write down for my second constraint?
S2.
Yeah, that's it, just S2. So that's a new slack variable so that it's an equation instead of an inequality. And now that's going to be our initial simplex tableau. We've got the x1, x2, s1, s2, z, and then a number. Is everyone using those labels all the way across? Okay, they're very helpful. Yeah, they are. Okay, so here we go. Nick, what's my whole first row?
Oh, Lord.
The Lord is not in the first row.
3, 4,
Yeah?
1,
Yeah?
0,
Yep.
and 4. No, 0,
Yep.
and 4.
Yeah, very nice, very nice. Julie, what's the next row?
2, 1, 0, 1, 0, 2.
Very nice. And then Carmen, what's the last row?
60.
Oh. What do we have to do first?
Oh, negative 60.
Yeah, we got to move everything over to the left. So negative 60x1 minus
and negative
40x2
40.
plus z equals 0. Okay, what are our numbers?
Negative 60, negative 40, 0, 0, 0, and then this is 2.
What goes in the z column?
Oh, z is 1 and
Yeah.
then 0.
Yeah, very good.
Sorry.
Okay. And folks, it's this, we just did it. We just produced those negatives in the bottom row that we now have to get rid of. By rewriting that objective function so that all the terms are on the left, that's what produced the negatives, which now our job is to get rid of the negatives by doing the simplex method. So we did the 0th step. We created our initial simplex tableau. So now we choose the most negative indicator, which is negative 60. So that's the column we're going to choose. And then which of those, 2 numbers up top do we actually choose?
2.
So the first one is 4/3. The next one is 2/2. So which is the smaller quotient?
2.
2. So we're going to choose that number to make zeros above and below it. Now, this really goes back to like elimination work. How do you eliminate a 3 with a 2? That's a bummer. You got to multiply both of them. So Lorena suggested that we should not multiply this row by a negative, but we're not adding into this row. We're not replacing this row. We're replacing this row. So I think we can multiply this by a negative if we want to.
That's where I was confused in the text. I was interesting.
Yeah, I think it's just if you're going to add it into its own row. Okay, so what are we going to do? We'll make this the top one negative times negative 2, and this one times 3. What did you do, Julie? What, the top one, the 2, and the bottom one, the negative 3?
Yeah.
Oh, that's fine. I'll do it the way you did it. So we have 6, 8, 2, 0, 0, 8. And then I have negative 6, negative 3, 0, negative 3, 0, negative 6. The key thing is we're changing the top row. So I'm not even going to change the middle row. The middle row I'm going to keep as 2, 1, 0, 1, 0, 2. Right? We don't have to change the middle row. Yeah. Okay, so what did we get? 0, 5, 2, 3, 0, and 2. And now the bottom row, we already have a negative 60, so I need this to be a positive 60. So I'll multiply by 30. So then I would have times 30, times 30, times 30, times 30, times 30, times 30. And then that will give us 0. Oh, still a negative number. And then 0, and then 30, and then 1, and then 60. Why was I so sad that it still produced a negative number? So now we do the whole thing over again. We do the, it wasn't that long, honestly, but now we just do that simplex method again.
Isn't it a negative 1?
Where?
30 minus 30.
Oh, yeah, thank you. That was a negative 10. Yes, thank you. Now, why can't we right now just multiply the whole bottom row by a negative?
Yeah.
Because then all these would be negative. Yeah, so you can't just get rid of it. Okay, so we do it again. This is obviously the most negative indicator. And then we do our quotients. That's 5 halves or 1 half. 1 half is smaller. Nick, do you see what I just did there? The 5 divided by 2, and then the 1 divided by 2. 1 half is smaller, so now that is our pivot. And now we go ahead and turn those into zeros.
Oh, you just can't just go straight to changing it to the negative.
We have to make sure we're choosing the right pivot. Yeah, you don't just automatically always go to the middle number. It could have been the top one that was better. Yeah. Okay, so here we go. I'm going to go ahead and get rid of the 5 first. Now, what did you all do? Did you multiply through by negative 5 on this one?
No, I did the multiply the top row by 2.
You multiplied the top row by what?
2.
2 to make it a 10? And then what did you multiply this one by?
I was doing that to the bottom row.
Oh, and then you use the bottom row. Oh, what do you guys think about that? Can we do that? Can we multiply the top row by 2 and then cancel it out with the bottom row? I think so. I think that's okay. I mean, there's no reason why not. But then again, see, I don't know if there's something special about the pivot, that we're supposed to be using the pivot in order to do these things.
That's how I was asking, like, when we, how we're just figuring times the negative 3 or.
Yeah.
We can't just automatically just keep going with that. We have to all of a sudden reset and find the pivot again and then go.
Oh, I see. So you were going to say, can we go ahead and now get rid of that 0?
Yeah, like, so all of a sudden just keep going to get rid of the negative. So we always got to start over and find it.
You should start over and find it again. For the reason being that if this was a bigger matrix with more variables, that's going to help you get there faster. Yeah. Okay, well, Julie, let us all know if your way works.
No, I'm just changing.
Well, no, that would have been so exciting for you to do that little experiment. We were all behind you. Okay, well, I'm going to go ahead and multiply the middle row by negative 5. So that way I've got negative 10, negative 5, 0, negative 5, 0, negative 10. And that way I can put my 0 in the top row. So that's negative 10, 0, 2, negative 8, 0, negative 8. My middle row stays the same, 2, 1, 0, 0, 2. And my bottom row becomes, well, now I just multiply by 10. Let's multiply by 10, so 20 times 10 is 10, times 10, times 10, times 10, times 10. Well, that would give us 20, 0, 0, 40, 1, and 80. Did anyone else get that?
It's 31?
Yeah, this is 31.
Yeah. Oh, I didn't get that.
You mean you didn't get that, or that's not what the back of the book says?
That's not what I got.
Oh.
Like my numbers in the end, yes, but I don't have a 20, I have a 0.
Oh, well, that's fine. Do you have the 0, 40, and the 180?
Oh, yeah.
Oh, okay. Well, I think that's the key thing.
But no.
What's your numbers?
Hold on. I think we were looking. I don't have that actually.
Folks, let's check the answer in the back. What does the answer in the back say? Is the max or the minimum of W 80? Say
No.
W equals 80?
We're doing number 31,
Yeah,
right?
this is 31.
No. Y1 is 4, Y2 is 24.
Wait, let me write that down. Y1 is what?
4.
Yeah.
Y2 is 24.
And what's the minimum?
W is 64.
Oh, jeez. So I just made some sort of mistake.
Yes.
I did this one last night, and I took a picture of it. I posted it online. So
I
this
think I might
solution
have
is-
originally got what you got, and then when I did it again, I got the correct answer.
Oh, so I might have just made a mistake. Okay.
Oh yeah, because that's what I have originally. Yep, that's my first one. What pivot did you choose? That's not the correct pivot.
What?
The one is not the correct pivot.
The one is not? How could that not be?
Because it's 2 divided by 5, right?
Oh, it is 2 divided by 5, folks. I made a rookie mistake. That's not the pivot. It's 2 divided by 5, and it's 2 divided by 1.
Mhm.
Wow.
I did the exact same mistake.
What a learning lesson. 2/5 versus 2/1. 5 is the pivot.
Yep.
What? What are you saying, Julie?
Yeah, like when you did that part, I was like, hold on, that ain't what you just did.
Ah,
in the
dang
last
it. You
part.
guys should have spoken
But I
up.
was like, I don't know. I was in
Yeah,
here.
no, you got it. So that would have been 2/5, so that's definitely the pivot. All right, so, well, that was a learning lesson. So let me. Okay, so now we're gonna use 5. So I'm gonna multiply. Oh geez, I'm gonna erase a lot of this now.
Is this where we can now do the top row and the bottom row?
What?
Is this now where we can do the top row and the bottom row to cancel out the bottom row?
Yeah, you can go ahead and cancel out the. Yeah, you can use the pivot row to cancel out that one.
Mhm.
Yeah, yeah. In fact, I suppose, do we even have to bother to cancel out this one to make it a 0? Because we're really just interested in the bottom row and what happens down there. So let's try. I'm gonna multiply this all by 2. So then that'd be 0 times 2 times 2 times 2 times 2 times 2 times 2. And then I'm gonna add that into the bottom row. So that gives me 0, 0, of course, 4, 24, 1, and 64. Oh man, there it is. So that is the answer. The slack variable is equal to the y variable, so y1 is 4. The slack variable is equal to y variable, and the y2 is 24. And then the maximum and the minimum are both 64. So the real pivot, the point of the pivot is just to help us make the whole bottom row positive. Seems to me we don't even have to make zeros elsewhere.
That's true.
Unless by making zeros as we go, it makes the operations easier as we go, by getting rid of all the extra terms. Okay, folks, well, we did it. We're all done. I suppose what might be interesting now, if you did have all those other zeros, we could actually solve for x1 and y2. Now, to Anna's point, Anna asked you earlier, what about the basic variables and solving for x1 and y2? I'm sorry, x1 and x2? We have no idea what the solution for x1 and x2 is right now. No idea at all. If we wanted to solve that problem, we would have to revert back to our old method of actually solving for the basic variables and creating zeros and ones in the first row of the x1 and x2 so we could actually solve that. Yeah. All right. Well, folks, I think that brings chapter 4 to a conclusion. Would anyone like to ask anything else right now with that? Now, Nick, obviously there's a lot more that was in chapter 4. But that was just the tail problem. The last couple.
We did it.
That's the expert part.
Yeah, fun food, yeah.
Your answers are. Yeah. 1 is 4. Times 2. Wait, I got 8. Oh, what was the answer in the back? I think I have them marked too. 24. Yes. Question.
Yeah.
24.
Yes.
I get different answers. I did it twice and I got different answers.
Ooh.
What
Okay,
the heck?
I really enjoyed this problem. Should we all do it?
Yes.
Yes.
You like that, Nick? What? Oh, okay. Jill Sharp, trick question. No one's name is Jill Sharp. Oh yeah, we started this problem.
We
Didn't we already
started
set
it.
it up?
Yeah, you can finish it.
Yeah.
No, we can finish it. We finished it?
No,
No, we just set it up.
We did.
No, just set it up.
All right, well, we knew that x1, x2, and x3 represented
Hours running,
Running.
hours walking, swimming, and
swimming and walking.
walking.
I don't have actually.
Oh, it's right here.
And it says there that she has no more than 12 hours a week. So that means that 1 plus 1 plus 1 should be less than or equal to 12. That's our first row of the matrix. And she can do at most 4 hours of running. So for the running,
One.
notice 1 is less than or equal to 4. And she wants to walk at least 3 times as many hours as she swims. So doing some scratch work here, walking has to be at least 3 times as much as swimming. So walking is my x3 variable. That has to be greater than or equal to 3x2. But we need all of this to be in the form of less than or equal to a number. So I need my variables on the less than or equal to side. So I'm going to move the x3 over here. And now I have 3x2 minus x3. Now we do have an inequality. I could rewrite it again. 3x2 minus x3 is less than or equal to 0. Now that's in a form that we can put into this matrix. So what would that be? A 3, a negative 1 is less than or equal to 0. How are we doing so far? Now it's just be a matter of plugging in all the zeros
And our.
and our slack variables and the objective function. So let's do our slack variables. How many constraints do we have?
3.
3. So how many slack variables do we have?
3.
3. So S1, S2, S3, as well as Z.
And 0. And the number.
Yeah. I need to make a little more room. All right. So the first slack variable goes with the first inequality, the second slack variable with the second, and the third slack variable with the third. And now we just have to plug in all these zeros. So 0, 0, 0. Okay, is that the same matrix we got last time?
Yeah, and then you have
Okay. And now we need our objective function. We can probably all imagine what's going to happen. We just turn all those numbers negative and put a 1 for the Z. Now, of course, that's really cheating. That's like just kind of skipping to what we know it's going to be. You would want to write out your objective function. But yeah, it would be the negative 528. Now, Nick, for you there, we're saying that 528x1 plus 492x2 plus 348x3 is our objective function. So if you plug in how many hours you're doing each of those things, that's going to tell us how many calories you burned. But we need everything on the side with the Z. In fact, I should write it this way. Z equals. I need everything on the side of the equation with the Z, so it equals 0. So each of these terms come over to the left, and they all become negative. So that's how I got negative 528, negative 492, negative 348, and then no slack variables and a Z. All right. Well, there we have it, folks. All we have to do is get rid of these negatives using the simplex method. I just erased the simplex method, but we choose the most negative indicator, which is 528. And then you do quotients the right way, not the wrong way. So what would that be? 12 over 1 is our first quotient, 4 over 1 is our next quotient, and 0 over 0 is undefined, so we won't choose that. So it's that one. Is that our pivot?
Yes.
Okay, here we go. I think for my part, I'm just going to multiply that row times 528 to immediately get rid of that. So that'd be times 528 times 528 times 528 times 528 times 528 times 528 times 528. Ooh, times 528. What is that?
528 times 4.
Yeah.
That says it is 2112. Okay. That's what I did. Okay.
So my bottom row only then is 0. Negative 492. We still have a negative. Negative 348. We still have a negative. 0, 0, 0. Oh,
Wait,
no.
it's not.
528.
If it's 528 minus 490 something, isn't it come up?
But there's a 0. Yep, I'm there with you. So far, so good.
So I think just to try it out, I'm not gonna bother to make that number a 0 up there. Or should we? Because later on, see, that might mess with things and we might end up.
Because I ended up using, for the second one, I ended up using the first row for the pivot.
Yeah.
But then now that maybe my pivots work.
Yeah, so we better get rid of it. But that's not that hard because it's a 1, that's a positive 1, so I just need to make this a negative 1. So I'll multiply that row times negative 1, so that's negative 1, negative 1, negative 1, negative 1, 0, 0, 0, negative 12. And then we add those together. So we got a 0, negative 1, negative 1, negative 1, 528, a 0, a 0, and 2100?
No.
The second row.
What did I do?
You're not using the blue numbers, you're using the regular black numbers.
Oh yeah, I'm not using. Oh my goodness. Yeah, I need to use the black.
So the
numbers.
528.
Of course.
Wait, time out.
So that's.
What, your rows kind of going sideways because that row that you wrote, that's the second row, and you did the bottom row, so. you're missing
Oh, there are
the-
4 rows.
Yeah.
Oh my gosh. Okay, so you're right. I should put a row in between that. So that's. Thank you, folks. 0.
Negative 1, 0, 0, 1, 0, 0.
And then 1, 0. 4. And then now I can just add them together. So that would be a 0. That'd be a negative 1. That'd be a negative 1. That'd be a negative 1. That'd be a 1. That'd be a 0. A 0. And negative 8.
Oh, yes, sorry.
All right. So we're done with our first simplex. And you'll notice I now have a really nice basic variable here. So theoretically, when we're all done, I might still be able to look at this and find out what x1 is equal to.
So this is an example of what we were reading on the textbook where since we're changing the top row, how it says to not multiply it by a negative.
Yes, yes.
See how
And
you did, I didn't multiply it by a negative, but I see that you did multiply it by.
you're saying I should have multiplied this one by a negative and added it to it?
That's what I understood from the textbook.
I can see why that would be because now I've got all these negatives up here.
So
and
when you
if I-
get your pivot,
if I
does
multiply by
that affect your
something,
pivot?
that could
Yeah,
affect
but
that.
if you would just multiply the first row by negative 492, you get all positive pretty much on top except for 1 negative.
No, but we first have to find our pivot.
And we need to find our next pivot.
So does that affect?
So should I do the thing that Lauren is saying and not multiply the top one by negative? Because it did produce quite a few negatives.
Wow. I mean, I guess in this case, it doesn't really affect it much because your numerator and your denominator are both negative, so the negatives will pretty much turn into a positive.
Yeah.
But I wonder if this is a situation where it wouldn't and how that
Right.
affects choosing a pivot.
Well, the worst case scenario is I'll have to go back. So I suppose I could go back and do what Lauren is saying and then we feel
Or
safe.
multiply by a negative.
Or I can just go ahead and keep on going and see what, oh yeah, see that did change that to a negative, which
Uh-huh.
our solution shouldn't be negative. So theoretically, don't I just have to change them all back?
Mhm.
So plus, 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 minus, plus, and now it's not even an issue?
Mhm.
Okay,
It really wasn't an issue.
sounds fine by me. All right, so now our next pivot is at negative 492,
Okay.
and our quotients are 8/1
0 and 0.
or
Well,
4 over
undefined.
0, which is undefined, or 0 or 3.
So then you get the first one as your pivot.
Yeah, it's supposed to be non-negative. So there's our pivot. Oh boy, this is really exciting. I think this will be our last move.
I think so.
Anna, did that work?
I'm just confused because you say you just multiply the first row by 1, right?
I multiplied the whole top row by -1.
To get rid
I
of
changed
the-
all the signs back to positive. Yeah. All right, here we go. We're going to pivot, put the 1 to get rid of this negative 492, which since we're going to add 492 into that, it'll also get rid of that negative as well, and we should be done.
Yes.
So, I multiply through by 492. So we have 0, 492, 492, 492. Oh no, negative 492, but
okay.
fortunately that's not going to turn that to negative. And then 0, and then 0, and then 492 times 8.
That's 3936.
Okay, great. Well, this is very exciting. So that gives me 0, 1, And then we have 1, 4. And then we're really just changing the bottom row, which will become 0, 0, 491.
No.
Oh, bottom row. You know, standing right up here next to the board is very challenging.
144.
144, thank you.
0.
And then 492.
0.
No, 492.
492. And then 528 minus 492.
36.
6. And then 0. And then
1.
1. And then whatever.
That, so we add those two, correct?
Yeah.
And that's 6048.
Yeah. 6048?
Yes. I will double check that. 21, 1, 2 plus 39, 36, 6048.
Yeah.
But those are not the answers in the back.
Really?
We did that twice. Got the same answer both times. So
What?
I don't know.
You mean 6048 is not the answer?
Or the other ones, the other numbers.
Well, I think we're not done yet, folks. We need to finish our slack here. See, this is a normal problem. This is back in section 4.2. So we would need to actually finish our basic variables, I think, for the x1
Yeah.
Somehow I got rid of the 3 already. Where did I get rid of it?
and x3.
Oh, I just got rid of it at the same time.
Let's just look at my work real quick to verify that, because I didn't do this one.
Yeah, because you were just multiplying. Falta deshacernos de este 3. Porque tiene que ser 0 si nomás 1 y aquí la misma. Pero es la misma gata porque aquí cuando cambias estas dos, esta lo cambias multiplicando por un negativo 3. Aquí arriba. Entonces cambia esta, pero de todas maneras, estas values for x1 and x2 are not the same.
Yeah, folks, we do in fact need to finish the echelon form over here to just have zeros and ones, and then zeros and ones.
But that wouldn't affect our z value, right?
It is. As we continue to do row operations over there, that's going to continue to add these numbers in over here.
Oh, I didn't. There's 3 variables. Okay.
Yeah.
I stopped at x2.
Ah, okay. So we're still on our way. We are definitely still on our way. And in fact, I have this exact setup in my notes. So we are doing it correctly. It's just going to take a couple more steps. So what do we want to get rid of? We need to get rid of this 3 as well as this. We need one of our x1s, one of our x2s, and then one of our x3s.
Yeah, so that will.
Oh.
Because we need a 1 in each of those rows so that we're definitely solving for x1, x2, and x3. Yeah, absolutely.
So we still have like 144.
Yeah, so we're going to keep this one as our solution for x1. We'll keep, and then I suppose it's up to us. We could either keep this one as our solution for x2, get rid of the 3, and then keep this one as our solution for x3 and get rid of that one. But we need to keep one row with a 1, one row with a 1, and one row with a 1. So we just have 2 more steps to do. So each of us on your own matrix, you could continue working on this, or you could, starting from left to right, folks, we definitely have to go from left to right. So I'm going to now eliminate the 3. That's what I'm going to do. Because I do need to get rid of that 3. So I'll multiply by -3, 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 by -3. Oh, this is just so hard to do up here. So it would be 0. -1, 8. And then I would have 1. Aha, so now this is going to be 0, and then -4, So this would be a solution for x1, this would be a solution for x2, so I still need this number to be a 1. Yep, which
One
is
or zero?
a 1.
Three has one on top.
Yeah, well, I need to get rid of that. So I'm gonna multiply this whole thing. Yeah, I'll go ahead and multiply that whole thing by 4. So then that'd be a 0, 4, 4, 4, 3, 4, 0, 0, 2. And that way I can finish out that solution, so.
1, 1.
4, 0. Did I do that right? 0 plus 0, 0
Oh, you
plus
did
4,
it
negative 4 plus 4,
Yeah.
negative 3 plus 4. Did I really?
Yes.
0, okay. And then this is still my 1, 0. And then this row, because I want that to be a 1, I'm going to go ahead and divide off the negative 4. Because I'm essentially done, I just need that to be a 1 now. So I'm going to divide everything by negative 4. So I have 1, 3/4, negative 3/4, negative 1/4, 0, and 6. Oh my gosh, folks, it's actually going to work. But what? Why did my bottom row change? Because I still have to get rid of the 144. This has to be a basic variable. I still have to get rid of that 144. Yep. Well, that's fine. It's fine that I changed that to a 1, because now it'll be easier for me to get rid of the 144. Which now I'll just multiply this row by negative 144 and add it to that one. Oh, but I'll have to actually do all that on the calculator. So folks, I think I should just be done up here because you all need to work out the solution on your own paper, and you probably diverged from my solution and you're working out your own solution, doing it in your own way. But the key is that to finish this problem, not only did we have to get to the point that the bottom row was positive, but we had to finish making each column a basic variable. Right? Does everyone agree that that's the method? So now, what's that?
What was that again?
That in order to finish this problem, you have to make the first 3 columns a basic variable, where you've got 1s and 0s only, and then the problem is done.
The 3/4 times the 144, just so you know, is 108.
Oh, thank you. I was about to do that on my calculator. So that's negative 108. That's positive 108. That's. Oops. Positive 36, that's 0. And then. Boy, this is time consuming work. So what do you think? 5 of these on the exam?
I think 1 should be fine.
Yeah, I think so too.
No more than 1.
It's a lot of them.
Yes, that's really good that it's not. The next one. Or you get 2 hours, so maybe when I get 3. Así, tú estás fallando, tú estás fallando. O es 8. Sé que yo lo pongo.
You know this?
Send that to the copy number.
Do what?
Practice book.
You know this?
I'll do it after class.
You're fine.
Oh,
Actually, pretty much you just like for this number.
Okay, well, folks,
Last number.
I think the key thing for us all to see is that it did work.
Yes, it did.
So I've got now that my x2, which represents swimming, is 2 hours. So x2 is 2, which is swimming. And my x1 is 4, so that's running.
I said. Okay.
And then my x3 is 6, which is walking. And then the total calories burned was 5184?
Yes.
Okay.
Okay.
All right.
There we go.
Now, who even asked about this one?
I did.
Okay.
Thanks a lot, Lauren.
No, that was a good one to see that it took a little bit.
I
No class, I won't have to have a test.
No, I still want something like this. I might try to find something that doesn't take quite as many steps.
I'm paying
Okay,
for
but
my
we're good,
class.
folks. Now, guess what? We are done with matrices for the class.
What?
Mm-hmm. Because now chapter 5 is all about finances, nary a matrix to be found. And then next week on Monday, we take a test over chapter 3, 4, 5. And I will email you the practice test tonight via PDF. And then after that, we do chapters, 7, 8, 9? And that's all probability and counting.
Oh.
It should be interesting, probability, not statistics, but probability. So we'll have fun with that. So, I didn't tell my joke yet. Here's your joke. Everyone, take a big deep breath. Here we go, we're gonna start the next chapter. But our joke, where do hardcore kids go camping? Where do hardcore kids go camping? Ready for it? Intense!